Okay, so this video is on integration by parts, which is kind of like the product rule backwards. So it's really going to help you when you have to integrate a product that you can't use a U substitution on. It's something that's not on the AP exam, so we typically cover it after. And the interesting thing is that college professors will really kind of expect you to know this pretty well. So I want to show you where it comes from. I'm just going to look at the product rule for a minute. And I'm going to do the product rule out and show you how rearranging it and doing some kind of things can get you this formula. You'll notice this formula in the huge red box at the top. That's the formula you just want to memorize. Sometimes I've heard it said that if you look at this side here, like let's say you know this part, and then this is ultraviolet voodoo. That's what some people say. So ultraviolet voodoo. So ultraviolet voodoo is one way to remember that. It's kind of a stretch, but it's worth a try. So it does help me because I know the formula generally. So when I think of ultraviolet voodoo, I'm good to go. So the integral of u dv equals uv, which doesn't have an integral, it's just two numbers that are outside of an integral, solved, good to go, minus the integral of v du. So when you apply the formula, you get the left thing to look like the right thing. You still have an integral to do, but probably an easier integral. So let's look at the product rule. I'm going to do out the product rule. So here's u times v prime, and then I do the product rule out. So if I was to do the product rule out, I would have the derivative of the first times the second, plus the derivative of the second times the first. I could then take that, and instead of writing u prime and v prime, I'm going to write du as in the derivative of u, and dv as in the derivative of v. Now the notation's not too much here. We don't want to worry about with respect to x and all that kind of thing. We just want to kind of talk about the product rule in a simple way. So everything should be okay there. I just put a times in to show you that it's multiplied. And I'm going to probably now integrate both sides because it's an integral formula. We don't even have an integral looking or showing up here. So if you integrate both sides, you see the fundamental theorem of calculus, the second fundamental theorem. So hopefully this is no problem. This is going to cancel out. You get a prime inside there, which is a derivative, and you get an integral. So generally those cancel out. So this is going to go away. And then on this side, you have two integrals. And you're going to basically isolate so you're dealing with one of those integrals. And that'll give you your formula, which can be helpful if we pay attention to what the formula really does. So once you've done that, you have this, which is the actual thing. We subtract this negative v, the integral of v du, so we subtract this on both sides. So we know that this goes away, becomes just that. And then here we subtract this integral of v du on both sides, of course. Here as well. Integral of v du, and we get this formula right here. uv minus v du equals u times dv in the integral, of course. So sometimes I forget to say integral as I'm reading through. But remember uv minus v du. So this is just us taking the product rule, doing it out, shuffling it around, using integrals, and showing how that formula came to be. Kind of helpful. You could even derive it if you needed to. It's not a hard one to come up with. So let's talk about how it can help us in our life. So the formula we want to have at the forefront for right now. So I'm going to pull this down here, down here. We want to definitely have that for sure. Let's talk about that for a moment. Just pause and let me just get my composure here, and I'll pause us for a second. All right, so now I'm situated here, and this is the example we want to deal with, and this is the formula we have. So we want to think about how we can use this formula, uv minus v du, on this thing. So what we could do is a couple of different things, actually. What I'd like to do is kind of show you the steps on how you're going to do this for starters. So the first thing you're going to do here is follow these steps right here. So let me get this out of your way so you can kind of look at what we're looking at. And even this can go away, I think. So here are some steps that you might find helpful. They're not printed, but we're going to try to choose u and dv. That's the first thing we're going to do. So what you want to do is you want to choose a u that's going to go away. Because if you look at your formula, right, the u is not going to wind up in that integral all the way over here. The u is not going to wind up in this integral. The v is, right? So if the u isn't going to wind up in the integral, that's good. We want something that goes away. So the x, that's not very mathematical, but the x will go away and wind up just as du, which will be dx inside the integral. So let's just do it, and I think it will come a lot more simpler then. Okay, so we want this to be our u. So u is equal to x. Now it says once we have u, we can just differentiate u. So if you want, I'll show you the idea. It's du dx equals 1, right? But we're going to move the dx over by multiplying it. So I multiply the dx over, so I end up with just du equals dx. Then we're going to choose our v. So we have that, which is going to wind up being those things later. We'll now choose our v, or our dv, sorry. Our dv is going to be everything else. So it should have a dx in it or something like that. So our dv is whatever's left, which is this, e to the x dx. Now here's the most difficult part, I think, is that we don't really have v yet. So we've chosen both things, and I'm talking to you about how to choose them a little bit later, but for right now we're good with that. And we differentiated u. But if we have dv, the derivative of v, and we want v, we need to antiderive or integrate that thing. So we can take a side note and just take a second and integrate dv. So we have, I think, we have the integral of e to the x dx, which is simply e to the x. So we'll put e to the x here for the plain old regular v. So notice that the dv has a dx in it, and the du has a dx in it. That's always how it should work, right? The derivative should have a dx in it if you're working with x, and the non-derivative shouldn't, right? Because it's going to wind up outside of an integral. So let's now just simply apply the formula. So we're working with all of these things now. We're looking here, and we're just trying to plug in what we know. So I'm just going to write down u, which is x. So what I'm trying to say is actually this, by the formula, is in fact equal to, so let's make this bigger now. By the formula, this is actually in fact equal to u times v minus the integral of v du. So that is what we've wound up with. So we started with that whole thing, so pause if you need to. I'm going to scroll down in a second. But we started with that one integral, and now we have this new integral. We traded one integral for another, and you'll notice that the u doesn't show up in the next integral. It's gone. The du shows up. So because we had x to the first power, right? We had x to the first power here. Well, now we have here, we have x to the 0th power, or just dx, right? If, for example, this was an x squared, this is just a side note, then you'd wind up with an x here, because the derivative, or a 2x there, because the derivative would have that in it. So you're going to lose a power of x if you choose your du to be a polynomial. And x is a polynomial, just a really nice, good-looking polynomial. We're not done if we have an integral there, of course, but it's not that hard now. We can simply realize that e to the x, or x e to the x is good to go, and we can integrate e to the x. A lot of times you've already done it, so this has already been done up above. So this is our example. So hopefully that made a lot of sense. I'm going to now show you how some tips and tricks on how you can pick a u that works for you. That's a good one. So yeah, so here's, to select u, use this process. So always pick u to be a logarithm if you can. If you don't have an ln of x, then use u to be an inverse trig. Don't worry, that won't be one that we cover. So we're not going to cover that this year. We might cover it some other time. P is polynomial, so x or x squared, something like that. So those are the ones you want to try, usually logs or polynomials. If you don't have any of those, then it's going to be exponential or trig. But for our purposes and with the time that we have, we're just going to use, we're just going to have logs or polynomials every time, basically. So let's try another example and kind of go through it. So I'm going to write on the whiteboard uv minus v du, so we don't mess that up again. And then we'll try example 2. So it's the integral, and then it's equals uv minus integral v du. And this, I think, is u dv. So that's the formula. So let's go to an example. Okay. All right, so if we use Lippitt, what should we use to be our u?
ln of x.
ln of x, good. So Lippitt says that ln of x should be our u. So let's just make a box and get all 4 things. Okay? So we have, let's see, u and dv. And where am I getting these from? I'm getting these from my formula on the left side. Those are what I'm looking at right now. So I either need to make u to be ln of x or u to be x squared, but we know that Lippitt says to make u ln of x. And dv is everything else, so it's x squared dx. So what we need to do now is figure out the other things. So du should be pretty straightforward. Just derive that top line ln of x, which is 1 over x. Don't forget the dx, that always comes up in u substitutions. And then dv is just anti-deriving that. So what I sometimes do is I just go over here and I like integrate x squared dx, which is x to the 3rd over 3. So I think v would be x to the 3rd over 3. And if you derived that, you would get dv. So now let's just apply the formula. I'm just going to put an equal sign. So that problem up there equals the following. So it equals uv, so I'll try to keep the colors together this time. That was horrible last time. uv minus integral v du du. So now all you need to do is solve the bottom line, which is a simple integral. We'll cancel out an x, we'll have 1/3 x squared, and then we could just integrate that. We don't need to do anything with anything that's outside the integral. When all the integral symbols go away, you're done. So just take a second and like look at what we've done, make sure it makes some sense. So we have the formula on the whiteboard. It's also on your paper if you're watching the video. We have u dv, so we just need Lippitt to tell us what to be u. Lippitt says log should be u, so I make ln of x u. I just derive it to get du. Everything else that was in there was dv, which is x squared dx. That's all in there as well. And then I just need to do a quick integral on that. It shouldn't be a difficult integral. Maybe like has a little bit of work to it, but it shouldn't be too bad. Then I just apply the formula. So the u and the v are outside of the integral, and I subtract the integral of v times du. So now I'm going to scroll down and just solve what's there. Okay? So now I just need to solve this. Well, the good news is that this is all done. So however you want to write this, 1/3 x to the 3rd ln of x, that's done. Don't worry about it. So here we can do 1/3 x squared dx, and that should all be okay, I think. All you got to do is solve that easier integral now. No product, nothing weird. So we're just going to have x cubed over 3 plus c. It's 1/3 of that. And it's 1/3 of this. So really what you have is, oops, plus c. You have 1/3 x to the 3rd ln of x minus x to the 3rd over 9 plus c. And that's it. So that's kind of what integration by parts is all about. So what's cool about integration by parts is it helps you to solve anything that's a product. You can't really integrate products anytime you have something multiplied unless you use integration by parts. So integration by parts will help you whenever you're doing a product. So that's probably enough for today. Oh, way over time limit. So we'll stop here. Peace.